Alkane nomenclature. Have you got it? This short video quiz assesses your ability to name alkanes using standard IUPAC naming conventions and your ability to draw the structure of relatively simple alkanes using standard IUPAC naming conventions. The quiz consists of 3 questions. It's meant to be taken after you've studied the material and think you understand it. During the presentation, you'll be asked to pause the video or at least try to solve the problem yourself and only then to continue. It won't be hardly as effective if you jump to the solution immediately. Okay, here we go. Name the alkanes shown below. Pause the video, pull out a piece of paper, see if you can do this. Come back and continue to see how you did. Okay, here we go. In the first case, we see first that we have 3 carbons. And then the one on the right is attached to 3 more carbons. And the one on the left is attached to 2 more carbons. All right, so the first thing we want to do is find our longest chain. That would be this one. I like to draw a little circle around it so that I can know all the things I have to name, all the things that are outside that circle. All right, if we start from each end, this would be carbon 1 or carbon 1, carbon 2 or carbon 2. Well, this one over here, this 2 has 2 methyls on it, so it wins with 2 methyls. I like to list my substituents. I have a 2, 3, 4. I have a 2, 2 methyl, and I have a 4 methyl. And it's going to be a 2, 2, 4 trimethyl. Our root is pentane. So this one is 2,2,4 trimethyl pentane. All one word. Okay, how about B? Looking for our longest chain. What have we got? We have across the top, we have 1, 2, 3, 4, 5, 6, 7. But look, we've got this long piece down here. 1, 2, 3, 4, 5, 6, 7, 8. So hiding in there is an octane. Now there's a methyl group and an ethyl group. And again, to figure out what the numbering is, we're going to start at both ends, call those 1, next one 2, next one 3, and you can see that this 3 over here wins. So what we have is a 3-methyl, and what we have over here is a 3, 4, 5, a 5-ethyl. And now alphabetically, E comes before M, so the name is going to be 5-ethyl 3-methyl octane. All right, with hyphens around the numbers to set them off. All one word. So far, so good. Let's try the C over here. Now this one is a cyclohexane, and it has a methyl and an ethyl. And the way it works on a cyclohexane is you have to have a group numbered 1, and it's going to be the alphabetically listed 1 in a case like this. So this is a 1-ethyl, and we're going to go to the smallest numbering to the 3-methyl. So 1-ethyl, 3-methyl cyclohexane. D. We have another ring. This time it's a cyclopentane. Okay, our substituents are a 1-methyl, another 1-methyl, and a 2-methyl. So here again, we're going to do 1, 1, 2 trimethyl cyclopentane. Just like that. Number 2, draw the structures of the following named alkanes. Pause the video, give it a try, and come back. I'll be waiting for you. Okay, we're back. Here we go. A, 3-ethyl 4,4-dimethyl octane. It's an octane. We need 8 carbons. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. 3-ethyl. 1, 2, 3. 4,4-dimethyl. There. 3-ethyl 4,4-dimethyl octane. B, 3-sec-butyl 4-ethyl heptane. Heptane 7. 1, 2, 3, 4, 5, 6, 7. 3-sec-butyl, secondary butyl. 1, 2, 3. On this carbon, we have a butyl attached at the second position. 4-ethyl. All right, there you have it. Now, there's something interesting about this one. Take a look at this. That is not our longest chain. If we look carefully here, there's a better name that has 8 carbons in it. 1, 2, 3, 4, 5, 6, 7, 8. This actually could have been named an octane. Now, we don't know why the person chose 3-sec-butyl 4-ethyl heptane. Maybe the context is that they were studying a whole bunch of heptanes and they just happened to have different groups on them, and so they wanted to name them similarly, and they decided to use 3-sec-butyl. It's completely fine. However, we can name this without all this hyphenated stuff by saying this is a 3-methyl, a 4-ethyl, using this numbering system for the octane, and a 5-ethyl. And E comes before M, so this is a 4,5-diethyl 3-methyl octane. Right? Alternative name, a better name actually. Okay, how about our 4-isopropyl 2,5-dimethyl nonane over here? Nonane, 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4-isopropyl. 1, 2, 3, 4. Here's our isopropyl, the propyl connected at the second position. 2,5-dimethyl. 2, 3, 4, 5. There we go. 4-isopropyl, 2,5-dimethyl nonane. All right, this one's a little different. Cyclohexane, 6 carbons in a ring. And we have a 1 tertiary butyl and a 4-methyl. 1, 2, 3, 4. There you have it. Here's a little challenge. Try to name these alkanes. What's the problem? And how does the IUPAC naming system allow us to get around this problem? Go ahead. Pause the video, see if you can name those. Are you back? For A, the problem is, if we try to name this as a cyclohexane, we've got a methyl group, that's fine. But over here, we have quite a little complex branch. What are we going to do with this? Well, actually, I want to show you how this is actually done in the IUPAC. What we do is actually a pretty simple system. We start here at this bond, this carbon where it's connected to the ring, and we just label that automatically, number 1. And we see what chains we have. So here, the longest chain is a propyl. And what's on this propyl? Well, 2 methyls here and here. So it's a 1,1-dimethyl propyl. Cool, huh? So that's a branch. The branch is called 1,1-dimethyl propyl. And it's a branch on the cyclohexane. And because it, as a full word, starts with di, with D, and this one starts with M, it gets the number 1 on the cyclohexane, and the 3 comes out over there. Now you say, well, we weren't supposed to count number D, but that's only for the longest chain. Everything else is just like you'd think it would be normally. So this is a 1 dash, all of this. And so what the IUPAC does is they just say, go ahead, do that. Just put it in parentheses. So this is a 1,1,1-dimethyl propyl 3-methyl cyclohexane. How about that? Not so bad. Let's take a look at this one over here. All right. Would you agree our longest chain is this? And what have we got there? Well, it looks like this is the short end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a decane. We have a 3-methyl. We have a 5-methyl. And what do we have over here on 6? Remember what I just showed you? Here's our longest chain on 6. So this is a 1-methyl propyl. And we already have a 3 and a 5-methyl. We have a 6 1-methyl propyl. And we just put these together. It's really 3,5-dimethyl, 6,1-methylpropyl, with the parentheses to set off this different numbering system for the branch. Cool, huh? So remember, the IUPAC naming system for alkenes is built on a set of relatively simple rules along with a fairly small structured vocabulary. Methyl, ethyl, propyl, like that. The system is designed to be flexible, allowing for context. You really can use different names. There's one name that's called the preferred name, but there are many other ways of writing IUPAC structures depending on what you want to emphasize. We'll talk more about this as the course develops. And the system can be extended to any organic compound, no matter how complex. We are just scratching the surface right now of how it works. Okay, well, I hope that was helpful, and I hope you got it.